This is the rising line used by official agencies as proof of global warming. But is it accurate? Professor Ross McKittrick is an expert in statistical analysis at Guelph University. He noticed something odd about modern thermometer records. Thermometers, even in the same region, give out very different readings, depending on where they're located.
I was interested in the question of how do you explain the spatial pattern of warming? So some places warm a lot, some places don't warm much. And it turns out it's highly correlated with the spatial pattern of economic activity.
Where there are more people and there is more human activity, there's more heat. This is known as the urban heat island effect.
Urban heat island effect is essentially London, right? You pick London. With buildings, with a lot of activities, tends to be a few degrees. I mean, we're talking now Celsius, right? Even 4 or 5 degrees Celsius warmer than outskirts. This is a phenomenon of urbanization. These days, the obvious effect is actually concrete retaining heat.
This can be illustrated with a satellite heat map of Paris. The center of Paris can be as much as 5 degrees Celsius warmer than the surrounding countryside.
Paris, London, Beijing, Shanghai, you name it, New Delhi, all of them absolutely demonstrated the effects.
So how has this affected the official temperature record? In the early part of the 20th century, it was normal to erect weather thermometers just outside towns, close enough to check every day, but away from the heat of urban life. But over the 20th century, those towns have expanded. Suburbs have spread. There are more roads, more cars. Thermometers which were once outside towns are now surrounded by shopping malls, offices, factories, and houses.
These towns and all the locations where thermometers are located, on average, they've all grown in population, let's say since 1880. You've got buildings growing up around the thermometers, you've got parking lots, so you've got all of these non-climate influences which are affecting the temperatures, which raises questions about the quality of thermometer data for monitoring global warming.
To correct for this corruption of the data, an obvious solution is to use only records from rural weather stations, which have been less affected by urban development. This has now been done by a team led by Dr. Willie Soon.
We combine all the best rural stations, anything that we can correct for, we correct for, and we show if you just don't use this data set and use only rural, you get a very different kind of picture.
According to rural temperature records, temperatures rose from the 1880s but peaked in the 1940s. Then there was a marked cooling until the 1970s. After that, temperatures recover, but are still today barely higher than they were in the 1940s.
What we see is that basically you have a warming from the 1850s or so to 1930s and 40s and started to warm and then cool in a substantial way to the 70s, about 76 or so. Instead of a long-term systematic warming trend, it has a variability, multi-decadal, like every 50, 60 years or so, kind of a variation.
It's not just rural thermometers that show little warming. Merchant ships and other naval vessels have been measuring the temperature of the sea since the 19th century. In red, we see the land temperature record since the 1860s, which has been inflated by urban thermometers. But in blue is the ocean temperature record. From around 1900, the two begin to diverge. Ocean records show far less warming in the 20th century, and the pattern more closely resembles the rural temperature record.
Sea is not supposed to be, quote-unquote, contaminated by urban heat island effect. Am I right? Yes? So when we compare the two records, within the range of uncertainty, this behavior actually fits.
Scientists have also studied temperature change by looking at tree rings, which again shows very little warming. There's a gentle rise till the mid-20th century, a cooling to the 1970s, followed by a mild recovery. Once again, it shows temperatures today are barely different to those of the 1930s and 40s, and the pattern closely resembles rural temperatures. Satellites, too, seem to be telling a different story. Our ability to measure global temperature accurately took a leap forward when satellites began to orbit the Earth. One of the scientists who pioneered the use of satellites to measure temperature is Dr. Roy Spencer. who in the 1980s was senior scientist for climate at NASA's Marshall Space Flight Center.
We were discussing over lunch, isn't there some way we can use satellites to monitor global temperatures? Because, as you know, the temperature network of thermometers is pretty skimpy around the world, so it's kind of hard to get a global temperature.
Dr. Spencer's development of weather satellites was revolutionary. He and his colleague, Professor John Christie, have been awarded NASA's Medal for Exceptional Scientific Achievement.
Our satellite data begins in January of 1979. That's when we have complete global coverage, and we have it right up to the present.
There was one critical question about temperature that satellites were singularly well equipped to answer.
Has there been a spurious warming that has crept into the global temperature record over land that's just a result of an increase in population? And that's something that we've been analyzing and working a lot on lately, and we're finding that, especially in urban areas, it's large. I mean, since 1880, most of the warming, it looks like, is due to the urban heat island effect.
We're lucky to have a few independent scientists like John Christie and Roy Spencer with their satellite measurements of temperature. You know, before they started releasing this, ground-based temperature records were going wild. They were going up, you know, like crazy with no bounds. But now they have to contend with the fact that there's this independent and probably better way of measuring the whole globe's temperature, which is not alarming at all.
Evidence from multiple sources now agree that the official global temperature record, as used by world governments and reported in the world's media, is showing far too much warming over the last 120 years, artificially inflated by urbanization.
You look at the weather balloon record, the satellite record, the rural record, the ocean record doesn't warm nearly as much as land. All of these indications show that the big warming pulse in the record is the Northern Hemisphere land record. And that's also where most of this data contamination is happening.
But of the mild warming that has taken place in the last 300 to 400 years, can any of it be attributed to human emissions of CO2? Professor Henrik Svensmark is visiting the Hebrew University of Jerusalem and taking a stroll in the Evolution Garden, dedicated to preserving the oldest surviving plant species on Earth. These plants aren't just pleasing on the eye. They can also tell us about levels of CO2 in the atmosphere in Earth's geological past.
What we have here is a ginkgo tree, and it's actually a living fossil in the sense that this type of tree first appeared about 270 million years ago. On the underside of the leaf, there are what we call stomata, the cells where they can uptake CO2. So they're actually measuring how much CO2 is in the air, and then they adjust the number of these stomata to how much CO2 there is. And by looking at fossils and measuring how many there are at a different time, it says something about what was the level of CO2 back in time.
So when we look back in time, what do we find? Over almost all of the last 500 million years, the level of CO2 in the atmosphere has been far, far higher than it is now. Even with modern industry's contribution to CO2 levels, by geological standards, the level of atmospheric CO2 today is close to being as low as it has ever been.
At present, we have about 400 parts per million. 50 million years ago, it might have been 2,000 parts per million. So a much, much higher concentration of CO2.
I think current estimates of global CO2 is 423 or so parts per million today. If we look through the Phanerozoic, the last 550 million years, we would see CO2 on the order of 7,000 parts per million.
CO2 is plant food, and the result of much higher levels of atmospheric CO2 in the past was a much, much greener world.
Periods of elevated CO2 tend to be time periods of a huge biodiversity on the planet. In fact, we're in a CO2 famine if we look over the last 550 million years.
At the depths of the most recent glacial maximum, the amount of CO2 in the atmosphere sank so low, all life on Earth came close to extinction.
They say CO2 is higher than it's been for 100,000 years, but what they don't tell you in that period they're talking about is that CO2 sank so low that all life on Earth nearly died.
20,000 years ago, CO2 is at the lowest level it has ever been in the history of the Earth, 180 parts per million. If it had gone down another 30 parts per million, we'd all be dead.
There is a low point of CO2 where photosynthesis becomes so inefficient that plant life would die. Then everything else starts to perish after that.
During the last glacial maximum, there's good evidence that in many parts of the world there was plant starvation from not enough CO2. So we should be very grateful that CO2 levels are beginning to go back up. We're still far from the historical norms, which would be several thousand parts per million. There's not enough fossil fuel to get there, but at least we're making a start.
But has the small recent increase in CO2 affected the temperature? We would now show you a picture of CO2, but we can't because it's invisible. CO2 makes up a tiny fraction of the gases in the atmosphere, just 0.04%. It is just one of 25 different greenhouse gases, which, taken as a whole, form only one part of Earth's complex climate system. So what evidence is there that this trace gas is having any noticeable impact on the climate? If it were true that higher levels of CO2 caused higher temperatures, we should be able to see that in Earth's climate history. Here, scientists are drilling into ancient ice cores. These cores tell us both about past temperatures and CO2 levels. Scientists have indeed found a link between temperature and CO2. The trouble is, it's the wrong way round.
So it's true over the last few million years of the ice age that we're in now that CO2 and temperature are correlated, but if CO2 is the driver, it has to change first, and the temperature has to change second.
In fact, when you start to look at the data very specifically, you see the exact reverse. Temperature starts to rise first, and then on the order of a century to a few centuries later, we start to see a rise in CO2.
It's long been known that the temperature actually moves first. So temperature goes up, CO2 goes up after that. Temperature goes down, CO2 goes down.
Ice ages start when carbon dioxide is at its maximum, and ice ages end when carbon dioxide is at its minimum, which is the exact opposite of what would occur if carbon dioxide was controlling the temperature.
The question of whether CO2 drives the climate is easily resolved. You can look back in time over hundreds of millions of years. CO2 levels have changed radically many times. Did this cause temperature change? No, absolutely not. CO2 has never driven temperature changes in the past, never.
Nor is it clear in recent times that CO2 is having any effect on temperature. Here we see industrial output of CO2 since 1750. From the mid-19th century to the mid-20th century, there was only a slight increase. It's not until the 1940s that industrial production of CO2 begins to take off. But this doesn't match the temperature record. According to rural thermometers, most of the warming in the past 200 years occurred before the 1940s and have barely changed since then.
One of the embarrassments that IPCC doesn't like to talk about was that the 1930s, when human influences were much smaller, were particularly warm.
That's the puzzle, that the first early part where we have such a sharp warming from the 1900s to 1930s and 1940s, CO2 could never cause the temperature rise.
But the 1930s and early 40s were so hot is puzzling. More puzzling still is what happened next.
By the end of World War II, CO2 was really going up.